students, this is the last question of previous video for your solution. Now, to find largest number of molecules, we have to calculate largest number of moles. As mass given, then number of moles is equals to mass in gram divided by molar mass. So, in first option, number of moles of water is equals to mass given in gram 36 gram divided by molar mass of water. Water H2O, so molar mass is 2 into 1 for hydrogen plus 18 gram per mole. So 18 gram per mole molar mass divided by molar mass is equals to 2 mole. 2 mole molecules of water. Now, in option second, 1 gram atom, as we know, 1 gram atom means 1 mole atom. 1 mole atom of oxygen, but oxygen molecule is O2, so number of moles of molecules will be number of atoms or number of moles of atoms, that is 1 divided by 2 or 0.5 mole molecules. As in option third, number of moles, mass in gram 46 divided by molar mass of ethanol also 46, 24 plus 5 plus 16 plus 1, that is 46. So it is 1 mole molecule. And in option 4, 50 gram of N2O5, again number of moles of N2O5 is mass in gram 54 divided by molar mass 108. As for N2O5, 2 into 14 plus 5 into 16, that is 108 gram per mole. But when mass is taken in gram and molar mass is gram per mole, then we can put direct 1 by 2 mole or 0.5 mole molecules. So the largest number of molecules, that is largest number of moles, will be in option first. Answer will be first. And now, guys, molar volume. Avogadro observed that 1 mole of a gas at STP occupies 22.4 liter, that is 22.4 liter of a gas at STP contains 1 mole molecule, that is 6.022 into 10 to the power 23 molecules. That is why 22.4 liter at STP is called molar volume, that is volume of 1 mole gas. But STP are the conditions of temperature and pressure. And what are the standard conditions of temperature and pressure? Temperature 0 Kelvin and 0 degree centigrade and pressure 1 atmosphere. The volume of 6.1 mole, that is 6.022 into 10 to the power 23 molecules of a gas at 0 degree centigrade and 1 atmospheric pressure occupies 22.4 liter. If we had to find the number of moles of a gas in its V liter of volume at STP, then number of moles of a gas is equals to its volume at STP in liters divided by 22.4 liter, that is volume of 1 mole. Volume divided by volume of 1 mole will give number of moles. we take a question. Find the volume of 5 mole nitrogen at STP. So guys, here we have to find number of moles from volume or volume of gas from moles. So volume of nitrogen is equals to number of moles, volume of gas is given here. The number of moles, 5 moles. Volume is asked. So volume is equals to number of moles of gas multiplied by molar volume, that is 22.4 liter. Number of moles multiplied by molar volume. Number of moles 5 and molar volume is 22.4 liter per mole. It is equals to 112 liter. Now another question. Find the number of moles in 11.2 ml of water. Carefully observe that this formula or this concept is valid only for gases, and we know water is not gas, it is liquid. That is why we should convert its volume into mass. We can't apply this formula because water is not a gas. So for its solution, we have to change volume into mass, and we know very well that density of any substance is mass by volume. That is why to find mass of water is equals to density of water multiplied by volume. Volume is 11.2 ml and density of water is 1 gram per ml at 4 degrees centigrade. It is a general information. So sometimes questions are based on general informations also. We will give another question based on general information, but now the mass of water is equals to density 1 gram per ml into volume of water is equals to 11.2 gram. So number of moles becomes simple. Number of moles, if mass is given in gram, then mass in gram divided by molar mass, and molar mass of water is 18 gram per mole. So it is simple. It is about 0.6, almost 0.6 mole. Or 62 mole. Anyways, as I say, few questions are also based on general information. For example, the next question is approximate volume of air having 2 mole oxygen at STP. As we all know very well that the volume of oxygen will be number of moles into molar volume 22.4, that is 44.8 liter at STP. But what is the general information? Oxygen is about 21% in air. Oxygen is about 21% in air. That is, the volume of air is almost almost, that is approximation, is almost 5 times of the volume of oxygen. That is why volume of air, which is asked in this question, volume of air is equal to 5 times of volume of oxygen, 44.8, that is 224.0 liter at STP. So your answer will be 224. What is the information? Volume of air is almost 5 times of volume of oxygen. Now, if we had to find number of moles from mass or change mass from moles, or find number of particles from moles, or we want to find number of moles from number of particles, volume of a gas from its moles, or moles from its volume at STP, then we have studied all these relations. When number of moles is changed into mass in gram, then it should be multiplied by molar mass. It should be multiplied by molar mass. Multiplied by molar mass. And if you want to find number of moles from mass, then mass divided by molar mass divided by molar mass is equals to number of moles. If you multiplied number of moles by Avogadro constant Na, then you will find number of particles, and vice versa. If you divide number of particles by Avogadro constant, then you will get number of moles. Similarly, if you multiply by molar volume, that is 22.4 liter at STP, with number of moles, then you will get volume of gas at STP. And if you divide volume of a gas at STP by molar volume, that is 22.4 liter, then you will get number of moles. In fact, the interconversion of these quantities is called above quantities is called mole concept. And for such questions, you have to remember, if mass is asked in the question from number of particles, then follow this path. First of all, change number of particles into moles and then get mass from moles. If you have to find the volume of a gas from its mass, then first of all, mass to moles and moles to volume. That is the simple concept for such questions. Is you have to follow track like this or track like this. You have to follow from mass to moles to particles, or particles, moles, mass. Mass, moles, volume. Volume, moles, mass. Is that clear, guys? You should not try to find volume from mass directly. Is that clear? Now guys, question, which had highest mass? We have to find mass from number of atoms. So, number of atoms to mole to mass. So first of all, we have to find, to solve this question, we have to find number of moles of carbon, number of atoms divided by Avogadro constant 6 into 10 to the power 23. It is approximation. 6.022 into 10 to the power 23 can be taken as 6 into 10 to the power 23 as approximation. So it is 1 by 6 mole. Now mole can be changed into mass by multiplying molar mass. So mass of carbon is number of moles 1 by 6 into molar mass. Molar mass of carbon is 12 gram per mole, so it is 2 gram. The mass of carbon is 2 gram. Now to find the mass of 44.8 liter, to find the mass from volume, first of all go to find number of moles from volume. So number of moles from volume is volume divided by molar volume. Volume is 44.8 at STP divided by molar volume 22.4 liter, so it is 2 mole. Now mass of oxygen is number of moles multiplied by molar mass, and the molar mass of oxygen is 32 gram per mole, so obviously 64 gram. The mass of 44.8 liter of oxygen at STP will be 64 gram. Now 1 gram atom of iron, 1 gram atom term is also used for mole, that is it is 1 mole of iron. And if you want to change mass from moles, so mass of iron will be number of moles into molar mass is 56, so it is 56 gram. And finally it is simply mass 50 gram. So the masses of the substances in first option is 2 gram, in second option 64 gram, in third option 56 gram, and the fourth option is 50 gram. So the highest mass is a 64 gram, that is second option.